Hello, let us look at some midterm review questions here. First set of questions are the solving exponential equations, as you can see from here. Let's look at A. Number A, we have 8 to the x power is equal to 2 to the x plus 6 power. When you look at them, what do you see between 8 and 2? You see 8 and 2 has the same base of 2. So that means 8 can be rewritten as 2 to the third power, as you can see, and raise the entire thing by x. And then the other side, I can just rewrite them as it is. Now, when you have exponent to exponent, what do? You got to multiply them, as you can see right over here. And then, now let's look at it. Since two bases have the same base of 2, two sides have same bases of 2, we can say that 3x must be equal to x plus 6. Now, then as you set this one up, as you subtract x from both sides, then we get 2x equals 6. So when you divide by 2, then x equals 3. Alright, then let's look at the second set of questions. Between 4, which is the base, and 1 over 16, what do you think the common base would have been? Okay, so I'm going to rewrite down the left side as it is. And did you realize that 1 over 16 can be rewritten as 4 to the negative 2 power? Then here you can see that 2x minus 3, which is the exponent, has to be equal to negative 2. So, once you set them equal to each other, then you can see that 2x minus 3 is equal to negative 2. As you solve for x by adding 3, then that's equal to 1. And then the value of x must be equal to 1/2. Alright, now let's look at the next question. X to the 3 over 2 power equals 64. Now the thing is this. I'm going to write down the question as it is one more time. But my question to you is, how can you get rid of 3 over 2 in the exponent? That's right. You can get rid of 3 over 2 of the exponents by raising each side by its reciprocal. Meaning, set the exponent, raise each side by 2/3 power. Now, of course, you can put 64 to the 2/3 power into your calculator to get the value of x. That would be perfectly fine. Or you can do it this way as well. So, as you can see, 3 over 2 and then 2/3, they cancel each other out by multiplying them. Then, denominator 3, as you can see over here, given us cube root of 64, and then we can raise the entire thing by 2 square. Now then here, what do you guys realize? Cube root of 64 in fact is equal to 4, and square that must be equal to 16. So that is the answer for number C. Alright, let's look at the next question. How about D? When you look at 125, the base, 25, the other base, what do you see in common? That's right. Both of them can be expressed as base of 5. You see, 125 is 5 to the 3rd power. So I'm rewriting that in that way. And raise the entire thing by negative 2x power. How about 25? As you know, that's equal to 5 square. And then I'm going to rewrite down the exponent as it is. Then between two exponents, we got to multiply them out. So we get 5 to the negative 6x power on the left side. How about on the right side? You see 2 will distribute to x plus 1. So we get 2x plus 2 would have been the exponent of the right side. Now then, when you set this one up, since bases are the same, just like earlier one, you can set the exponents to be equal to each other. Then we get negative 6x must be equal to 2x plus 2. Alright, now we just have to solve for x. Now by subtracting 2x from both sides, then we get negative 8x on the left equals 2 on the other. Obviously, by dividing by negative 8, x then must be equal to negative 1/4. Becomes our answer for D. How about number E? You see we have A, which we have to solve, but plus 2 is kind of in our way, so we want to get rid of plus 2. So how do you do this one? By adding 2 to both sides. Then 2 will cancel out, and 25 becomes 27. So just like before, how do you get rid of 3 over 5 as an exponent? We have to raise by it's a reciprocal, which is 5 over 3. Now, that means on the left side it becomes simply A. On the right side, I can rewrite it as cube root of 27 because denominator of 3 can be cube root and raise the entire thing by 5th power. Then, yes, cube root of 27 is equal to 3. Now we just have to raise that by 5th power. Then we get 243. That becomes our answer. Okay, let's go for number F. This question is a little bit seems a little bit more complex than before, but we'll try to do it one more time together. And just like earlier in question E, we have to get rid of this 2 first by subtracting 2 from both sides. So I'm copying everything except 2. It must be equal to 75 because by subtracting 2 from both sides. Now the next one that I want to look at is, you see this 3? That has to be cancelled somehow. And how are we going to do that? Since 3 is multiplying, as we undo by dividing it by 3, we can now see that 2m plus 3 to the 2/3 power must be equal to 25. Alright. Now then, our next layer which we have to get rid of is the 2/3 of the power. Notice that exponent of 2. Because since the exponent of 2, just like x squared, when you square something and then try to undo that square, we always have a positive and negative. So remember that. That means we're going to do the 3 over 2 power, because that's the reciprocal of 2/3 to both sides. Then we get to see that 2m plus 3 is equal to, what are we going to get? You see, when you look at this 2 as a denominator of the 25, then in fact we're going to have plus or minus square root of 25. Because even if you have a negative number over there, when you square, then it becomes positive anyway. So we have to consider both cases. Then plus or minus 5 to the 3rd power, which essentially becomes plus or minus 125. Now, in fact, we have minus as well. So let's talk about 2 different cases. What if we have first case is 2m plus 3 is equal to positive 125? What would have happened? Then subtracting 3 from both sides, as you can see, then 2m must be equal to 122. Then how do you find the value of m? By dividing it by 2, then we get to see that 61 should be one of our answer. Now, how about the second one? Second one is, by setting it up as negative 125 and subtracting 3, then you can see that 2m must be equal to negative 128. By dividing it by 2, what do you get? X equals negative 64. That becomes our answer. Alright. So now, then we have the next set of questions, rational expressions. When they say simplify, all we have to do is factor and cancel. Alright. Then how about the first one? You see that 6x is common in both cases. So we have, when you factor out 6x, we are left with x plus 2 on the numerator. How about on the denominator? We can factor out x because x was common in all 3 terms. Here, here, here. Now, then we will end up getting x squared minus 5x minus 14. But the question is, can I still factor further? In fact, that portion can be factored into I'm just gonna copy down the top portion, and then it becomes x and x, as you can see. That's right, -7 and +2 will be the numbers that multiply to -14 but add up to -5. Alright, now, then I think we can cancel a couple of things out here. X plus 2 cancels out. X cancels out as well. So we are left with 6 over x minus 7. That becomes our answer. How about number 3? Let's look at that together. So I'm going to factor the numerator. Then two numbers that multiply to -24 and add up to -2. I believe it is -6 and +4. Alright, and then how about the bottom one? I can factor that out as x plus 4 and x minus 4. And you can see that x plus 4s are common in the numerator and also denominator. So as you cancel them out, what's left is x minus 6 on top, and then on the bottom, x minus 4 would have been the answer. Alright, that's how we can simplify them for now. Alright, number 4. We need to find the value or values of x where the fraction is not defined. What does that mean by fraction being not defined? That simply means denominator. That's when the denominator is equal to 0. That means in this case, first case, the denominator is x minus 2. So when x minus 2 is equal to 0, then the fraction is not defined. By adding 2, you get to realize that x must be equal to 2. When x equals 2, the fraction is not defined. Number B. In this case, we just have to have the denominator, which is 6x, has to be equal to 0. For what value of x, 6 times x becomes 0? That's right, you get to see that x must be equal to 0. Alright, how about the third case? You know what, in this case, I don't really care about the numerator, but I do care about the denominator. Because when denominator is equal to 0, then the entire fraction is not defined. So I'm going to write that x squared plus 6x plus 8 must be equal to 0. Then simply I'm solving the quadratic equation. So here, x plus 4 and x plus 2. Okay, has to be equal to 0. That means x must be -2 or -4. So in fact, in this case, we have two answers. Alright, let's look at number 5 and 6. Alright, so what we want to do is we want to combine them as the operation that's given, and then express them in simplest form if possible. Alright, first one, when you look at x plus 4 and x as their denominators of the two fractions, what is the common denominator? Since there is nothing common, it looks like x was common but not, because x and 4 is addition, it's not multiplication, so x is not a common factor, which means number that divides. So in this case, our common factor would have been x plus 4 times x. Then when you look at the first fraction, you get to see that x is missing factor from the common denominator. And then from the second one, x plus 4 was the missing factor. So we are multiplying that in the top and bottom. Now, then our first fraction, I'm just going to rewrite down the denominator. As I multiply 3 times x, then we get 3x. That's not bad at all. How about the second one? Denominator stays as it is, and 2x plus 8. That's right. So then that's what we end up getting. Since now we have common denominator, we can combine the numerator as it is shown, saying that 5x plus 8 would have been our new numerator, given that denominator is still x times x plus 4. That becomes our answer. How about this number 6? First, we're going to try to factor everything that's possible. So when I factor out 5, then I'll be getting this trinomial. Now, I know that I have to factor this one further, but I'm just going to write this one as it is for now. And denominator x was common, so I have 4x minus 1. How about the second fraction? Denominator is the same. Now, actually I miswrote down, instead of writing x minus 4, I wrote x minus 1, but I'm going to change that later very soon. And when I factor the numerator, I get negative 5 and 2 as the two numbers. And then here, as I'm factoring the denominator, I move that to the front because division by a fraction is the same thing as multiplication by its reciprocal. Since 2x is common, then we get to realize that 4x minus 1 becomes out the other factor. And the numerator now becomes denominator, and as you can see, x minus 5, and then x plus 3 becomes the factors. Now, let's try to cancel things out. Well, actually, I forgot to write down 4 here. Then 4x minus 1 and x minus 5 cancels out here. Anything else? Oh, x is canceled out just now. Alright, so I'm just going to rewrite this one, and this time I'm going to factor the x squared minus x minus 12 in this manner. Now, what's left on the denominator? Only 1, and then from second fraction we have x plus 2 over x minus 4. Okay, that's given. The last one is simply 2 is left, and x plus 3. Now what else cancels out here? X minus 4 cancels out. X plus 3 cancels out. That means simply 10 times x plus 2 becomes our answer. Now, if you, even though that is the correct answer, if you wanted to distribute them, 10 to x and 2, that's also fine as well. If you have done that, then the answer would have been 10x plus 20 would have been the answer. Alright, so how about the next one? Number 7. As you can see, we don't have the common denominator. You see the x plus 4, we know that that factors into x plus 2, x minus 2. But we only have one of them, which is x plus 2. So therefore, we have to multiply the second fraction by x minus 2. So that we can have common denominator. On the numerator as well, x minus 2. Alright. Then, I'm just going to rewrite everything, x squared minus 4. And then rewriting that the first one. And the second one carries the same denominator. And right now what I'm doing is x plus 4 times x minus 2. Then I get x squared from the x times x. Not 2x. Because 4 times x becomes 4x minus 2 times of x becomes negative 2x. Therefore we get 4x minus 2x becomes 2x, and then the last one is 4 times negative 2 becomes negative 8. When I combine everything together, I just have to be careful about that. 2x squared minus x squared becomes x squared, but did you notice that the negative sign impacts 2x and negative 8 as well? So we get negative 2x, because positive 2x becomes negative. Negative becomes positive, so here we get negative 16 plus negative 16, and then plus 8 becomes negative 8. So when I factor the second time around, we get x minus 4 times x plus 2. And then denominator becomes x plus or minus 2. Then you can see that x plus 2 cancels each other out. Then then our answer is x minus 4 over x minus 2 becomes the final answer. Alrighty. Let's look at number 8. When you look at number 8, did you realize that we can factor this one as x plus 2 times x plus 1? Then notice that we already have x plus 1, so we are missing x plus 2. And that's exactly what we like to multiply on the second one. Now, then as we continue further, so how about the first one? Simply x minus 1 writing down the same denominator, x squared plus 2x. Now, when you combine, denominator, I'm going to just rewrite them as it is. When you combine the x squares, we only have one x squared. And 3x because x from here earlier. And 2x from here. And minus 1. Alright, so, but in this case, there is nothing else for us to factor further. So I'm just going to stop here. Alright. Let us look at number 9. In this case, how do you approach the fractional equations? One of the easiest way which you can do it is multiply everything by the common denominator. What is the common denominator on number 9? It will be equal to 6x. So we're going to multiply each one by 6x. Then from the first one we get simply 1. How about the second one? X is cancels out, 6 times 8, which is... Now, the last one is equal to x squared because 6 and 6 cancels out. Then, here we get x squared is equal to plus or minus 7. That's basically what we end up getting. How about number 10? Number 10, we see that 2x minus 12 is essentially 2 times n minus 6. So our common denominator is 2 times n minus 6, and that's what we're going to multiply to all three terms. So I'm going to rewrite equation with just a little bit of space in between. Alrighty. Now I'm going to multiply by 2n minus 6. 2n minus 6 in all three locations. Now then we just have to cancel out or divide the common factors here. X minus 6 cancels out. And then we are left with 2 times 4n plus 3. How about the second one? You see, n minus 6 and 6 minus n, when they cancel each other out, we have negative 1 sign left over. So negative 1 times 2 becomes negative 2 times whatever is remaining, which is n minus 4. Third one, whole thing cancels out, we get 44. Alright, so if you have to calculate them further, by distributing 2 and then by distributing negative 2, we'll end up getting this equation. So 8n minus 2n becomes 6n, as we know. And then, by solving for n by subtracting 14, then n equals 5. Alright, so we're just going to stop here for now, and I'll continue very soon. See you later. Bye-bye.